Alrighty, so today we're going to be going over a theorem that we actually have been using probably since middle school. The sum of the measures of three angles of a triangle is 180. What does that mean? If you add all three interior angles of a triangle, the sum of the three angles is always 180. We actually now have enough knowledge to prove this theorem. You don't have to write anything down. You can just sort of follow along while I show you. So I'm going to use the parallel line postulate that says through, if I have a line, so I have BC and I have a point out on that line, I have A, I'm allowed to draw exactly one line through A that will be parallel to BC. So I'm going to do that. I'm going to draw exactly one line through A and say that it is parallel to BC. Now, when I draw that line through A, do you all agree that I've now created three angles here, angle 1, angle 2, and angle 3? And now, what do you realize about the sum of angle 1 plus angle 2 plus angle 3? What do we know? Angle 1 plus angle 2 plus angle 3. What does that have to equal? You know, AJ?
180.
Good. Why 180? Good. Don't all three of these angles add to make the straight angle? So we know angle 1 plus angle 2 plus angle 3, all three of these angles together make that big straight angle. All right. And now what we're trying to prove is that the three interior angles of a triangle equal 180. So what we're trying to prove is that angle B plus angle 2 plus angle C equals 180. This is what we want to prove. The three interior angles of a triangle add up to 180. Well, using the parallel lines, we've learned a whole bunch of theorems that could help us out here. Do you all see the Z? What does that mean, that angle 1 and angle B are what? Congruent because of the alternate interior angles. So we know angle 1 is congruent to angle B. Now we have a Z on the other side. Do you all see the Z? What does that mean? Angle 3 and angle C are congruent. So I know this to be a fact. Angle 1 plus angle 2 plus angle 3 equals 180 because of the straight angle. And by definition, a straight angle always adds to 180 degrees. But now it's saying angle 1 plus angle B are congruent. Well, since angle 1 and angle B are congruent, can I take angle B and substitute it in for angle 1? And since angle 3 and angle C are congruent, can I go to that top equation and take angle 3 and substitute C in for 3? So if I make my substitutions based on the congruency, isn't it going to be angle B plus angle 2 plus angle C equals 180? Isn't that the sum of the interior angles of a triangle? So I just thought that's pretty cool that now you had enough knowledge to prove that, why that's true. All right, let's keep going. All right, an exterior angle of a polygon. An exterior angle of a polygon is if you take a polygon and you extend one of its sides to create an outside angle. That outside angle is called the exterior angle. So in all of these diagrams, angle 1 is the exterior angle. It's the angle that falls on the exterior or the outside of the polygon. Okay, definition. An exterior angle of a polygon is an angle that is adjacent to and supplementary to an interior angle of a polygon. I may have skipped this, but when you have an exterior angle, there's names for the interior angles. So the outside angle is called the exterior angle. The angle that's a supplement to the exterior angle, the angle that's a supplement, so let's call this 2, 3, and 4, The angle that's next to the exterior angle, or is a supplement to the exterior angle, is called the adjacent interior angle. And the angles that are far away from the exterior angle, those are called the remote interior angles. Now we have a theorem. This theorem will only be used in algebra problems, so you don't have to memorize it. You just have to understand it. So it's saying the measure of the exterior angle is equal to the sum of the measures of the remote interior angles. What does that mean? That's telling us that the exterior angle, angle 1, has to equal angle 3 plus angle 4. Let me tell you why. Why is this always true? Well, do we agree that angle 1 plus angle 2 is equal to 180 degrees? Angle 1 plus angle 2, because they're supplements. They make the straight angle. All right. Do we also agree that angle 3 plus angle 4 plus angle 2 equals 180 degrees? Angle 3 plus 4 plus 2, because they're a triangle. All the interior angles in a triangle have to add to 180 degrees. So what is this saying? It's saying angle 1 is a supplement to angle 2, and then it's also saying angle 3 plus angle 4 are supplement to angle 2. Well, what do we know about supplements of the same angle? Supplements of the same angle are congruent. So what does that mean? Angle 1 has to be congruent to angle 3 plus angle 4. That's what this theorem's telling us. This theorem's telling us that the outside angle has to equal the sum of the remote interior angles. All right, so it says the measure of angle 1 is 150. So this angle is 150. And then it says the measure of angle D is twice that of E. The measure of angle D is twice that of E. Do we all agree if D is twice E, E is the smaller angle? If D is twice E. Since E is the smaller angle, I'm going to go ahead and call E X. And then if D is twice that, how would I represent angle D? 2X. All right, now we need to find the measure of these angles. The way we're going to find the measure of these angles is using that theorem. It tells us the exterior angle equals the sum of the remote interior angles. So I'm going to say x plus 2x has to equal the outside angle, which is 150. So here we're going to have 3x equals 150. So x will equal 50. So if x is 50, angle E is 50, angle D is 2 times 50, which is 100. And what about angle DFE? How many degrees does that have to be? 30, you got it. Okay, next theorem. This theorem is called the midline theorem. Again, we're only going to use this midline theorem in algebra problems, so you don't have to memorize it, you just have to understand what it does. So the midline theorem tells us a segment joining the midpoints of two sides of a triangle is parallel to the third side and its length is half the length of the third side. What does that mean? So let's say I have a triangle. You don't need to draw this, just pay attention. I have triangle ABC, and I tell you that D is a midpoint of side AB, and I tell you that E is a midpoint of side BC. So now the segment joining those two midpoints, so that segment that I just created, DE, is going to be parallel to the base, and it's also going to be half the length of the base. So if AC is 30, that means DE has to be how many units long? 15. That's what the midline theorem tells us. If you connect the two midpoints on the legs of a triangle, that segment that you've just connected the two midpoints will be parallel to the third side, and it will be half the length of the third side. All right, so let's look at this example. So here we have G and J are midpoints. So if G is a midpoint, then GH and GF are congruent. And if J is a midpoint, JH and JK are congruent. And now we're asked to find all of these angles. The first angle we're asked to find is angle H. The way we're going to find angle H, does everyone see the really big triangle we have right here that I just highlighted in yellow? Well, don't I have one angle that's 70 and one angle that's 90? Right? What do all three angles in a triangle have to add to be? 180. So if this is 70 and this is 90, won't this last angle H have to be 20 to add up to 180? So we figured that one out. So angle H is 20. All right, the next angle we're asked to find is angle HGJ. That's this angle right in here. All right, well, if G is a midpoint and J is a midpoint, can I use the midline theorem? The segment connecting the two midpoints, I'm using the midline theorem here, the segment connecting the two midpoints will be parallel to the third side and half the length of the third side. Well, if it's going to be parallel, we could use all those parallel line theorems that we learned. So what are we looking for? We're looking for F's or Z's or C's. We're looking for one of those letters. I see an F. Do you all see that F? So what does that mean? If angle F is 90, then angle HGJ is also 90 because of the F. All right, now we want to find angle HJG, which I'm highlighting in green, this angle right here. And again, I'm going to use the parallel lines. So remember, this line and this line are parallel. I'm going to change the transversal. Now I'm going to use this transversal. Do you all see that F too? Created another F. So look in the armpits. If angle K is 70, angle GJH is also 70. Now, I didn't ask this, but let's say I told you that GJ was 20 units long. If GJ is 20 units long, how long does FK have to be? 40, double its length. You got it. Can I move on to the next problem? Okay. All right, let's do some sample problems. All right, we want to find X, Y, and Z. In order to find X, Y, and Z, I'm going to use the triangles we have. How many triangles are there? How many triangles are there in the diagram? Ready? It's not a trick question. How many triangles do you see? Nora? Three. There's 3 triangles, right? We're going to go and use each of these 3 triangles to help us. I'm going to start off and I'm going to find X. In order to find X, I'm going to use this triangle right here. Why did I choose that? Because in this triangle, I have 2 out of the 3 angles. If you have 2 out of the 3 angles in a triangle, can you always find the last angle? Yeah, because it has to add up to 180. So, using this blue triangle, we have x, we have 100, and we have 80, not 80, 60. So what does that mean for x? What does x have to equal? 20 to add up to 180. Okay, now I'm going to jump to angle y, and I'm going to use this yellow triangle. In this yellow triangle, I have an 80 and a 55, and I have y. So I'm going to go ahead and I'm going to add 80 plus 55, which is going to give us 135. And then what am I going to do with that 135? Subtract it from 180. And what do we end up getting? I heard it. No? 45? All right, now we need to find z. How am I going to find z? Do you all see this little purple triangle? Well, before it was x, y, and z, but didn't we already find values for x and y? So now we're going to use the purple triangle. We know x is 20. We know y is 45. And we have to find z. So we're going to do it the same way. We're going to add the two angles that we have. We're going to say 45 plus 20 is 65. Then we're going to do 180 minus 65. And we're going to end up with 115. Sure. Anybody still copying this? We're good? All right. Next one. It says the measures of the three angles of a triangle are in the ratio of 3 to 4 to 5. Find the measure of the largest angle. Hey, what do you need to remember? Well, I'm going to go ahead, I'm going to make a diagram. And the three angles in this diagram are in a ratio of 3 to 4 to 5. You need to remember that the minute you pull numbers out of a ratio, either put them in a diagram or put them into an equation, what must you put with those numbers? A variable. Excellent. So we're going to go ahead. Instead of 3, it's now 3x. Instead of 4, it's 4x. Instead of 5, it's now 5x. And we want to find the measure of the largest angle. In order to find the measure of the largest angle, we need to solve for x. Any ideas on how we can solve for x? You got it. If you add up all the interior angles in a triangle, the sum is always 180. So we're going to have 3x plus 4x is 7x plus 5x is 12x. Anybody divide this? What do we get? 15, thank you. All right, now we want the largest angle. Didn't say find all three angles, it said find the largest angle. So which one would be the largest, the 3x, the 4x, or the 5x? 5x. So now we're going to have 5x is equal to 5 times 15, which is 75. Okay. So it says if one of the angles of a triangle is 180 degrees, find the measure of the angle formed by the bisectors of the other two angles. Okay. I was really nice because I gave you the diagram for this and I marked the diagram with variables for you. If this were on a test, would I do that? No, I wouldn't do that. Okay, so what do we need to know? If one of the angles in a triangle is 80 degrees, there's our 80 degrees. Find the measure. This is what would probably throw you for a loop. Find the measure of the angles formed by the bisectors of the other two angles. What does it mean to bisect an angle? Split it into two what? Congruent what? Angles, exactly. If we're going to bisect an angle, we're going to split it into two congruent angles. So it says find the measure of the angle formed by the bisectors of the other two angles, which means I'm going to take angle B and I'm going to bisect it. I'm going to take angle C and I'm going to bisect it. And then I'm going to join these two bisectors to make an angle. Now, when you bisect an angle, you get two congruent angles. So these two angles are congruent. And these two angles are congruent. And we want to find the angle formed by the bisectors of the other two angles, which means I want to find this angle up here, which I'll call W. I need to find W. All right, well, looking where W is, I have triangle BEC. Do you all see triangle BEC? And we have X plus Y plus W has to equal what number? 180. I'm going to write that out. But is there any way to find that X plus Y plus W equals 180? Is there any way to find what just W equals? There's no way. So I'm going to try to look further. Is there another equation I can make? Especially because we're using different variables. When you use different variables, it pretty much tells you you're going to have to set up a system of equations, which means you're going to need two different equations. So we got this first one, X plus Y plus W equals 180. All right. Well, isn't there another triangle here, triangle BAC? Do you all see the really big triangle? Now, in the really big triangle, if we add up all those angles, angle B is not just one X. Isn't angle B an X plus another X, which makes it what? 2X. And then angle C is not just one Y. Angle C is one Y and then another Y. So a Y plus a Y gives us 2Y. And then angle A, isn't that 80? So we have 2X plus 2Y plus 80 equals 180. What do you think I'm going to do with that 80? I'm going to subtract it, exactly. So we're going to have 2X plus 2Y equals 100. Does anybody see anything I can do with that 2X plus 2Y equals 100 to make it simpler? We can divide that whole equation by 2 to make it a little bit smaller. So it's X plus Y equals 50. All right, so now I'm going to line up my two equations. I have, oops, oh no, don't freeze. Please don't freeze. All right, I have X plus Y equals 50. That's one equation. My other equation was X plus Y plus W equals 180. Think of what this is telling us. This is telling us anytime I add X plus Y, what is the sum? 50. This first equation is telling us anytime I add an X and a Y together, my sum is 50. Well, in this bottom equation, aren't I adding an X plus Y? So what does that have to equal? An X plus a Y has to equal 50. So what I'm going to do is I'm going to take this X plus Y, replace it with 50. So now I'm going to have 50 plus W equals 180. So what does W have to equal? Oh no. There we go. What does W have to equal? Subtract that 50. And we get W is equal to 130. All right, let's do another problem. If the vertex angle of an isosceles triangle is 100 degrees, find the measure of one of the exterior angles at the base. All right, I'm going to come up with a diagram. So it says if the vertex angle of an isosceles triangle is 100, find the measure of one of the exterior angles. So that means I have to make a triangle and create an exterior angle at the base. So I'm going to extend the base to create an exterior angle. I will call that angle 1. And it says this is an isosceles triangle. What does it mean if it's isosceles? What does it mean if it's isosceles, the triangle?
At least two sides are equal.
You got it. At least two sides are congruent. So my legs have to be congruent. And then it says the vertex angle, so the angle on top is 100. Well, didn't we learn that if the legs of a triangle are congruent, what else has to be congruent? The base angles have to be congruent. So that means this angle and this angle have to be congruent. Are we able to find these two angles? Yeah, if a whole triangle has to add up to 180 and the vertex angle is 100, doesn't that leave 80 degrees left over? Since these two angles have to be congruent and they have to add to 80, each angle has to be 40. So if the adjacent interior angle is 40, what's its relationship to the exterior angle? They have to be supplement. So what does that mean for angle 1? 140. You got it. Okay, I want you guys to do